Okay, so here I've set up an example. This is the second in a series of switching videos, short videos that I'm making. Here I've set up an example with a 6x6 switch. And so the first step in creating an n by n switch with 3 stages in it is to choose how you're going to divide the n inputs into some blocks. Okay, and so anytime we have an n given, we can take that n and make it the product of two numbers. Here I've made it n is equal to 6 is equal to 2 times 3, and I can have 3 input switches at my input here. Okay, what I'm going to do is I'm going to call each of these input switches an n by k switch. So each of these is an n by k switch. And in this case, we've chosen little n to be 3 and k to be 4. Okay, so each of these is an n by k switch. And the number of them is big N divided by little n. So this is 6 over 3, which is 2. This is the number of stage 1 switches. Okay. And what we need then is we need to have the number of outputs on this first stage equal to the number of switches in the second stage. And that way we can take the top one to the top of each of those switches. And then the number of inputs in the second stage is equal to the number of first stage switches. So we can take the bottom to the bottom, for example, in this case. Okay, so you can see that the number of output ports on the stage 1 switches is equal to the number of switches, the number of stage 2 switches. We also see that the number of input ports on the stage 2 switches is equal to the number of stage 1 switches. And same thing on the way back out, okay? And the output is always symmetric with the input. So top to top, second one down to second one down, third one down to third one down, and for bottom one to bottom one, okay? So this is how these things are hooked up. And these switches in the middle, the size of them is big N divided by little n by big N divided by little n. In this case, they're 2 by 2. Okay, so, and then here at the output stage, they are k by n, k by little n switches. So these are 4 by 3 switches, these are 2 by 2 switches, and these are 3 by 4 switches at stage 1. Okay. And the number of switches here is n by little n. The number of switches here is k in stage 2, and in stage 3 the number of switches is big N divided by little n again. Okay, so this is sort of the basic math of these switches. And so the question is, how many 2 by 2 elements are there in here? Remember that each n by k switch has n times k 2 by 2 elements in it. Okay, based on the complete 2 by 2 square configuration, or the n by m square or rectangular configuration that we talked about in the last video. And so the total number of switching elements that is 2 by 2 switching elements, we're going to call big M, and that's equal to it's equal to n times k for each of these little guys, and there are n by n of them. Here there are how many are there in the center? There are k of them in stage 2, and there are n by little n of switches at stage 3. Okay, and so the total number of 2 by 2 switching elements here is the number of switching elements per switch times the number of switches in the stage, plus the number of elements per switch in stage 2 times the number of switches in stage 2, and then stage 3, being symmetric with the input stage, has the same number of 2 by 2 elements as stage 1. So in stage 1 we have n times k switching elements per switch, and we have capital N divided by little n of them, of those switches. And so that's the number of switching elements in stage 1. I'm going to multiply that by 2 to stages 1 and 3, and then I'm going to add the number of switches in stage 2. Well, each of them is an n, big N divided by little n, by big N divided by little n switch, and there are k of them. So I'm going to get big N squared over little n squared. That's by multiplying these two numbers, and then I multiply that by k because there are k of those switches. And so you can see the little n's cancel here, and I get 2k big N plus k n squared over little n squared is the final number of switching elements in this three-stage design that I just showed here. Okay, I think I better end there and do another video after this.